Okay, so here we have a question that is very similar to question number 4 on your compound interest practice sheet. You've got 2 questions in this, so we'll do part A and then I'll do part B separately. So this is, what would you pay today for an investment that makes payments of $25 per year at the end of each year for the next 3 years at 7.2% compounded annually? So let's just make sure we have an idea where this is coming from in your textbook. This is chapter 11. And we're going to be using formula 11.2. And formula 11.2 looks a lot like this. Present value equals, payment. Hi, I'm recording. Outside of one minus bracket 1 plus I to the power of, and we'll put this in brackets, negative n. And all that's divided by I. So that writing it out that way makes almost no sense whatsoever. So let's try looking at what it would look like if we were able to write it properly. So this is present value equals payment times 1 minus bracket 1 plus I to the power of negative n all over I. Luckily, I was able to format these things a little better on the formula sheet. So what are we going to do with that nonsense? Well, let's see what we've got here. To start with, we know the payment equals 25 bucks. And we know I 7.2%, and n equals 3. So when we plug those in, I won't bother typing it out because it'll look ridiculous. Let's write it out. It'll look like it makes a lot more sense. We're solving for, oops, we're not solving for anything that way. Present value equals the payment of 25 times 1 minus 1 plus 7.2% to the power of negative 3 all over 7.2%. And when we plug that into our calculator, what is that all going to look like? Let's take a look at it. We're going to start with 7.2 we're going to hit the percent key, plus 1 equals, we can see what that is, but we don't want to take it out of our calculator. And then we're going to go y to the x, three, but the 3 has to be negative, so we're going to have to hit plus minus key. And then we're going to go equals, and we can see what that is, but we don't take it out of the calculator. And now we've got a number, but we got to take it away from 1. So instead of taking it away from 1, we're going to make this number negative. So we're going to hit that plus minus key again. And now we can go plus 1, because adding a negative amount is the same as taking away. And we were going to see what that equals, but we don't take it out of the calculator, of course. And now we have to go divided by the 7.2% again. And we want to see what that equals without ever taking it out of the calculator, and go times 25 and see what that equals. And what do we get? I get 65.3689 0134. But of course, we don't want all those decimals because we're dealing with money. So this is 65.37. So again, it's nice to know how the formulas work. Notice the formulas are getting uglier as we go. So let's head over to Excel and see if we can make this work. So we'll stop sharing this. And go over here. Get rid of this. Move my beautiful face out of the way and hit Excel. And we created these calculations for business math. So we can grab that. Here's our question 3, but we're not going to copy question 3. We're going to copy question 2 because we're looking for the present value. So let's copy that over to here. Change this to question 4A. That's a Canadian saying 4. And let's fill in some values here. The rate is amazingly enough 7.2%. We're good. The number of periods is 3. But we have a payment now. The payment is 25. Oh, the future value, what was the future value? We shouldn't have to worry about. So we'll put 0 in for future value. And we're getting a payment of 65.37. And does it make sense that it's negative? Let's see. The payment we're getting, yes, we're getting the $25 payment out of this. So this is how much we would have had to invest. So if we invested $65.37, at 7.2% for 3 years, we could get back $25 per year. So it makes perfect sense. And let's take it back to our calculation. Copy that. Go back to new share here, whiteboard, share, try text again, Control V, and yes, 6537. Notice when we calculated it, it just turns out to be a positive value of 6537 because when we calculate it by hand, we're not concerned with the cash flow concept. When we calculate it on Excel, Excel is worried about the cash flow concept. And so if we're getting a positive $25 out of it, we had to put the 6537 into it. So it's reasonable that this should end up looking like a negative number. If it, in order to make it look like a positive number, we'd have had to put the 25 in as negative, which wouldn't make any sense whatsoever. So let's go back to Excel here and let's save this so we don't lose that. Then we can put that away, and then I can stop sharing and hit